Hello everyone and welcome. Today, we are diving into a fundamental concept in organic chemistry called epimerization. You might already be familiar with isomers, molecules with the same formula but different structures. We are going to focus on a very specific type of relationship between stereoisomers and the process that connects them. So, what exactly is epimerization? Let's break it down. First, we need to understand what an epimer is. Epimers are a special type of diastereomer. Diastereomers are stereoisomers that are not mirror images of each other. Epimers take this a step further. They are diastereomers that differ in configuration at only one single chiral center. Think of two complex molecules that are almost identical twins, but the left hand of one is switched to a right hand, while everything else remains exactly the same. A classic example comes from carbohydrate chemistry. Consider the sugars D-glucose and D-galactose. Both are 6-carbon sugars, and they look incredibly similar. However, if you look at carbon number 4, you'll see the hydroxyl group on D-glucose points one way, and on D-galactose, it points the other way. Every other chiral center is identical. This makes them C4 epimers. Similarly, D-glucose and D-mannose are C2 epimers because they only differ at carbon number 2. Now, epimerization is the actual process of converting one epimer into another. It's the chemical reaction that inverts the stereochemistry at that single chiral center. This process often happens under specific conditions, frequently involving a base. A common mechanism involves the formation of an enolate intermediate. For example, if there is a carbonyl group next to the chiral center, a base can remove a proton from that center. This creates a planar, sp2 hybridized enolate ion. Because this intermediate is flat, the stereochemical information at that carbon is temporarily lost. When a proton is added back, it can attack from either the top face or the bottom face of the planar enolate. Attacking from one side reforms the original molecule, while attacking from the other side forms its epimer. This usually results in an equilibrium mixture of the two epimers. This isn't just a textbook concept, it's incredibly important in biology. Our bodies have enzymes called epimerases that specifically catalyze these reactions. For instance, an epimerase is crucial in metabolism for converting UDP galactose into UDP glucose, a key step in carbohydrate processing. Understanding epimerization is also vital in drug synthesis, where controlling the exact 3D shape of a molecule is critical for its function. And that's a brief overview of epimerization. It's the inversion of a single stereocenter that connects two special diastereomers called epimers. Thank you so much for watching. If you found this explanation helpful, please consider liking this video, subscribing to the channel, or leaving a comment with any questions. Your support allows us to continue making educational content. Thanks again, and we'll see you in the next video.